our next speaker will be Stefan Waizmann from SWS-Vistek, who will speak about make the invisible visible with IMX990 SWIR-Sensor. So, Mr. Waizmann, we are really looking forward to this topic. The stage is yours.
Thank you very much. Well, what I would like to show you is a short introduction into the IMX990 technology. IMX990 is a new SWIR sensor produced by Sony. And then this new sensor has some benefits which are quite unique. There are a lot of SWIR sensors already on the market. But the new Sony sensor has been made in INGAS technology, has 2 or 3 big benefits. The first one is it's relatively high resolution. There's a 1.3 megapixel version available. The second one, it's very, very sensitive to light, so you don't need too much of illumination. And the third, and according to my personal opinion, the biggest advantage of this sensor is its wide spectral sensitivity. Before we talk about the practical impact of these 3 advantages, we have to talk a little bit about theory. What is SWIR? Shortwave infrared is normally defined in a small range from 0.9 to 1.7 micrometers wavelength, but you'll find in literature also some definitions from 0.7 to 2.5 micrometers. So all these definitions are outside of the visible range. The sensor is not made with silicon. Silicon has a physical barrier at about 1 micrometer. So SWIR sensors, in most cases, are made in indium gallium arsenide technology, which are responsible for the wide wavelength range. What we have to consider as well, if you want to build a SWIR system, is you need lenses specifically adapted to SWIR. In this case, now it's a little bit special with lenses. Let's talk about this later on. So why are we wanting to use SWIR technology? It allows to reveal object characteristics invisible to the naked eye. So we can see things what we cannot see with our naked eye. We can see through plastics or silicon, through any material. We can reveal invisible elements like water, lipids, collagen. We can see through opaque elements, fog, dust, and visibly the same color materials can have different contrast in the SWIR spectral range. So we can distinguish materials which are, to our naked eye, pretty much the same. At our booth, you can see it live. It's a white table with white salt on it, with white sugar on it. You would do hard with standard technology to make to distinguish these materials. It's pretty simple with SWIR. What we see on the images here, we have, for example, a bottle with shampoo. Well, the bottle is black, but we can see the amount of liquid inside. We can see the distortions in wafers, in silicon wafers. We can see damaged or rotten fruit. We can see the rotten fruit even before we can see it with the naked eye. So the apple might be still perfectly all right for us if we take it in our hands, but the SWIR camera will reveal that there's already a degrading process going on. Yeah, and we can distinguish the same naked eye colors to different materials. Where is this technology being used? Well, in the semiconductor industry, solar cell, chip inspection, recycling industry, medical, metal, and glass industry, you can show temperatures above 250 degrees Celsius. You cannot compare this with a thermal camera. It's not a thermal camera because thermal cameras are covering wavelength with even longer wavelengths till up to 12 microns. But temperatures above 250 degrees will show a precise value of temperature. You see it in agriculture. Agriculture, for example, you can see the amount of water in the leaves. You can see if some leaves are bad or they are sick. You can reveal secrets in banknotes, for example, to verify the authenticity of banknotes. So you have hidden secrets. You can do laser beam profiling to have a more efficient laser spot. Well, and security is one range as well. Now, the camera what we're showing on our booth, it's FXO, FXO990 with the IMX990 sensor, featuring 134 frames per second and at a resolution of 1.3 megapixel. And we have a maximum dynamic range of 57 dB, which is excellent. We have an excellent homogeneity, and this is all in a package like a standard industrial camera. Now, how is this being made that the sensor is this good, this flat? First of all, there's a silicium layer at the bottom of the sensor, and the indium gallium arsenide layer is bonded with a copper-copper connection, which is much smaller than traditional connections, the traditional bump layer, and this permits the small structures. As a second benefit, the indium phosphate cover, permitting shorter visual wavelengths, is much shorter. With traditional SWIR sensors, this cover is much thicker, which is blocking the standard RGB wavelengths. Now this is visible. The result is stunning. Yeah? Please have a look on this graph. You see the quantum efficiency, and it's quite easy to see. We're starting at about 400 nanometers. We're going up to 1700 nanometers. That means we have one sensor covering visible and SWIR range in one camera. This has advantages. If you want to do some inspection, in most cases or in many cases, for example, you want to do an inspection in the SWIR range, whatever it is, and you want to be pretty sure that you're inspecting this a special object which is marked with a label or whatever. That means you can do With one camera, you can take the visible image, and with the same camera, right away, you take the SWIR image. That means you do material inspection and optical inspection in the SWIR range with a single piece of camera. What we see on this spectrum as well is we have a high quantum efficiency, even at low frequencies. We have additionally, we have a very good homogeneity, what I said already. We have a low noise, extremely low noise. The sensor is available as a TEC sensor or TEC-less sensor. The TEC sensor is cooled with a Peltier element. The cameras what we are providing are TEC-less, and we are special. You might know our name, our brand. We are specialists for large sensors, and large sensors have temperature issues normally. So our competence is also to have an extremely good heat dissipation all over the sensor. We made this technology available for the SWIR cameras as well, which leads to an extremely good homogeneity and, as a result, to this very, very good dynamic range of 57 dB. There's a disadvantage of this camera in the practical appliances, and that's a wide spectral range of 400 to 1700 nanometers, which is astonishing in the beginning, but if you take this camera first time in your hand, you will see it. You will have a lot of light coming from the visible range, and you want to inspect. The SWIR range. Now, the first thing is the choice of lens. It's essential to use a lens that is designed and optimized and especially coated for the SWIR wavelength range. Using a lens designed for the visible spectrum will result in lower resolution images and higher chromatical aberrations, resulting in larger focus points. So if you have a non-corrected lens like this, you have the blue is very close to the lens and the red is very far. The red focus point is very far from the lens, so you have a large focus point. If you correct this, well, your focus point will get smaller. This is cold coffee, but for the SWIR camera with an extremely wide range of wavelengths, this has practical implications because you can do the chromatical aberration correction only in a small bandwidth. If you do it for the visible range, well, we're talking about 480 to 720 or something like that. That's fairly simple. If you talk about correcting a lens from 400 to 1700, it's complicated. So please be aware that if you want to do some inspection in the SWIR range, try to get some inspection on wavelengths which are close together. Only like this you will have the benefit of two sharp images at both wavelengths. The more far the wavelengths are on the other side, the more unsharp the image will be. The environment is the second thing what you have to be aware of. What I said before, in many current SWIR applications, the visible light is engaged. This is not possible with the SWIR sensor anymore, with the IMX990. The visual environment light will reduce SWIR contrast significantly. So what you need to do is use camera filters blocking unnecessary light and use a dark environment with lighting in the requested wavelength range only. And, well, quite naturally, short exposure times reduce the influence of disturbing ambient light. Identifying materials is a difficult thing. We're talking about materials which have absorption lines, specific absorption lines per material. And you have several materials which have very, very characteristic absorption maximums. You'll see it here in the table. What you will find is not only one absorption line is defining a material, you will have to take images from a combination of absorption lines. That means you probably will need several different lightings. Yeah? What you will do in most cases is you have one camera, you have 3 or 4 different lightings at 3 or 4 different wavelengths, and you take 3 or 4 images in a very short sequence, one after the other. So you see the relations, the brightness relations between these images, and can identify your target precisely. The Sony SensWIR technology is made available from SWS-Vistek in the FXO series and in the EXO series. The FXO series is faster. It features Co-Express 12 interface. It features and the EXO is the standard GeniCam GigaVision interface. So what you need to do is, in the camera decision, determine the need for the cooled or the uncooled versions, the techless or the tech version. Make the speed decision. Is GigaVision sufficient? And think about multi-channel strobe control. Our cameras do feature a multi-channel strobe control already integrated in the camera, because this will facilitate your application development very fast. Well, basically that's what I wanted to tell you. It's mostly from the practical point of view how you want to operate a SWIR camera. I thank you very much. Goodbye.
Thank you, Mr. Waizmann, for the presentation and for showing us how to integrate the SWIR sensor and providing a ready-to-use camera module. Unfortunately, we have actually no time for a question, but let me ask, is it deliverable?
Yes.
Can we buy it?
Well,
because of the current situation?
Well, yes, it is deliverable. Well, but there are some legal restrictions in terms of SWIR cameras and SWIR sensors. But well, come to our booth, ask, and yes, it is deliverable.
Okay, okay. So if you have any further questions and want to have a look on the systems, join the booth of SWS-Vistek.